Let's take a look at graphing linear inequalities. I'm going to start by showing you how to use the tool to graph a linear equation. So this one that says y equals negative 3/2 of x plus 1, we know the y-intercept is 1, so I'm going to click on the line, and I'm going to go to the point 1, and I'm going to put a dot. This immediately puts a line in, so I'm going to use the slope to come up with a second point. So I want to move down 1, 2, 3, and then over 1, 2 to get a second point, and then I can submit my question to see that I got it right. So the same thing continues to happen as you're graphing. You always start by picking what you're going to graph, which again, in this case is a line, starting at the intercept, and then using the slope to pick a second point. If you get to a problem like this that's not written in slope-intercept form, you know that you're going to rewrite it so that you can see the intercept and the slope before you graph. As we continue on and look at linear inequalities, our graphs have to be shaded. The first piece you'll do is pick which type of boundary line you want. Do you want a solid line to show inequality of the boundary, or do you want a dashed line to show a strict inequality? This problem says y is less than negative 4x minus 2. Since it's strictly less than, I want to pick the dashed line. I'm still going to use my slope and my y-intercept, so I'm going to go up here to negative 2. Then I'm going to use the slope of 1, 2, 3, 4, and then over to the right 1. Now my line is set, I need to pick which region is my solution. So you can pick a particular point, plug it in and see if it works, but I find it's just easier to think above or below. Less than is below, so I click a point underneath my line, which forces the program to shade it. You submit the question to see that you got it right. If you have a problem that allows equality, so this says y greater than or equal to x, then I want to pick the solid line to start my graph. This one has an intercept at 0. It has a slope of 1 over 1. And then I'm going to pick above the graph this time because it's greater than, and I'll submit the question. If we get a question like x minus 2y is less than 6 that's not written in slope-intercept form, we're going to start by rewriting our inequality. I'm going to isolate the y by subtracting x from both sides. That gives me negative 2y is less than negative x plus 6. Really important, when I divide by negative 2, I need to remember to reverse my inequality. This will say y is now greater than, I had a negative x over a negative 2, so now this is 1/2 of x. 6 divided by negative 2 is minus 3. We're going to go over to the graph, go down to the intercept at negative 3, use the slope of up 1 and over 2. There's my second point. It's a strict inequality, so I know I need to dash my line, and this becomes the boundary of the region. So I just need to decide, am I above the line or below the line? Because it says greater than, I know I'm above the line, and I'm going to do my best to shade in the solution. I'll just use some lines, kind of make like a little chart to show you this would be the answer if I was drawing this by hand. So make sure you slow down enough to decide what kind of boundary line do I have, dotted or dashed. Remember to put everything in slope-intercept form. Then if you multiply or divide by a negative number, remember to flip the sign of the inequality.